Hi. I wanted to take a few minutes and do a dimensional analysis problem. This one says a typical waterbed will hold 28 cubic feet of water. If a cubic foot of water weighs 64.2 pounds, how much will the water in the waterbed weigh when filled? Okay, so using dimensional analysis is really all about using and identifying the units stated in the question. So we want to figure out a relationship between all of our units that we can use to set up our conversion fractions. So in this one, it says that one waterbed, I'm just going to write WB for short because I don't want to write waterbed a whole lot. One waterbed is the same thing as 28 cubic feet of water. That's how much one waterbed would hold. You're not going to put more. You really wouldn't put less. So in our dimensional analysis problem, these two concepts are interchangeable. Okay, and the other relationship that's being identified in our problem statement is that 1 cubic foot of water is the same thing as 64.2 pounds of water. So it's 64.2 pounds. So I know the relationships here now. This is asking me to figure out how much the water in the water bed is going to weigh when I fill it up. Because I know these relationships, I can set them up as fractions in order to change the units around. So I'll know the relationship between the one water bed and its weight. Okay, so that's the goal. I'm looking for water bed and weight to be in the same fraction. Now, one does not necessarily have to be in the numerator or in the denominator, but it does determine what we do with our second fraction. So, for instance, I could say one water bed divided by 28 feet cubed of water. Okay, now I can use my other equation here to set up a fraction. And remember, I want to know how much this waterbed is going to weigh. So that means I need my cubic feet of water to cancel itself out when I do this multiplication. So there's 1 cubic foot of water from my second equality statement here. And that is going to be divided by 64.2 pounds. Okay. Now, approaching this problem, my feet cubed of water is going to cancel out my feet cubed of water. And multiplying across in the numerator, 1 times 1 is 1. And I still have my water bed as my unit. And that's going to be divided by 28 times 64.2 is 1,797.6 pounds. Okay? So the answer to my problem really is that one waterbed will hold 1,797.6 pounds of water. Okay, let me scroll down just a little bit. Right now that we can see our completed work on top and our problem statement, I'd like to readdress this problem again one more time because I did say it doesn't really matter the way we set up our fractions. For instance, I could have said that 28 feet cubed of water was in the numerator and one waterbed goes in the denominator. And so thinking about my equations that I set up, I still need feet cubed of water to be in the to be canceled out as I approach this problem. So when I write the second fraction, I need to flip that second fraction upside down. I need to take the reciprocal of it. So I've got 64.2 pounds over 1 feet cubed water. Now, my feet cubed of water is still going to cancel out my feet cubed of water. And that's what we need to be looking out for. My final answer, I end up with 1,797.6 pounds over one waterbed. So that really didn't change. The important thing here was that I ended up with both pounds and waterbed in my problem statement. It's giving me the relationship between these two objects now, weight and waterbed, as my units.